Today we're going to learn about the mole. Now, how do we define the mole? The mole can be defined as the Avogadro number of particles, or units of a given substance or species. Here, the capital letter L is used to denote the Avogadro number, which is 6.02 times 10 to the power of 23. Now, the mole is the SI unit. It is the SI unit for the amount of substance. It's a dimensionless quantity, and it's the SI unit for the amount or the quantity of a substance. So it is the SI unit for the amount of substance. Now, the mole can be thought of as a unit of count or quantity or amount of a substance. Think about what we mean when we have a pair of something. When we say we have a pair of something, it means that we have two of something. Similarly, when we say we have a dozen of something, like we have a dozen eggs, for example, it means that we have 12 of that thing. And the mole is often referred to as the chemist's dozen. When we say that we have a mole of a substance, or we have a mole of a particular species, what we mean is we have 6.02 times 10 to the power of 23 units or particles of that substance or species. So just like a pair means two of something, or a dozen means 12 of something, a mole simply means we have this many, that is 6.02 times 10 to the power of 23 units of that something. Now, what's the point of using the mole in chemistry? Why use such a large number? Well, to understand this, let's try to figure out the mass of 1 mole of hydrogen atoms. So the question is, what is the mass of 1 mole of hydrogen atoms? Now here I want to figure out the mass of 1 mole of hydrogen atoms in grams. And if we go to the periodic table, we see that the relative mass of a hydrogen atom is 1.0. That is 1.0 atomic mass units. That's the relative mass of hydrogen atoms. But the actual mass of hydrogen atoms to 4 significant figures is 1.674 times 10 to the power of negative 24 grams. That's roughly the mass of a proton. This is roughly the mass of a proton. In the periodic table, this mass to 1 decimal place is 1 atomic mass unit. So 1 atomic mass unit is roughly 1.674 times 10 to the power of negative 24 grams. Now, since we want to figure out the mass of 1 mole of hydrogen atoms, we want to figure out the mass of this many hydrogen atoms. That is 6.02 times 10 to the power of 23 hydrogen atoms. Now, we know the mass of 1 hydrogen atom is 1.674 times 10 to the power of 24 grams. And you want to figure out the mass of 1 mole of hydrogen atoms, that is 6.02 times 10 to the power of 23 hydrogen atoms. And when we multiply these two, what we get is the mass of 1 mole of hydrogen atoms is equal to 1.0 grams. So that's a very convenient result, because what we've done here is, what we've said is, if you look at the periodic table, the relative mass of hydrogen atom is 1.0 atomic mass units. That's roughly the mass of a proton. That's 1.674 times 10 to the power negative 24 grams. And if we just figure out the mass of 1 mole of hydrogen atoms, we get the same value that we had for the relative mass, but in grams. And that's really why we use the Avogadro number, or why we use the mole. Previously, if we wanted to figure out the mass of 1 mole of hydrogen atoms, we just look at the relative atomic mass in the periodic table. That would be 1.0 atomic mass units. And we just convert it directly into grams. And the reason we can do that is because the Avogadro number, if we multiply the mass of a hydrogen atom, that's roughly the mass of a proton, that's 1 atomic mass unit, that is this many grams here. If you multiply that by the Avogadro number, we can convert from atomic mass units to grams. And that's the utility that the Avogadro number serves. What it really does for us is that it helps us convert from this tiny, tiny, tiny scale to a scale that we use in everyday applications.